November 18th, 2023 is the day that's going to go down in space history. SpaceX has successfully figured out how to launch their Starship with a hot separation because of their last test, the Integrated Flight Test 2. We're going to talk about what that mission was, how it compares to that first flight test where we saw it go out of control, never separate, and then eventually blow up. The launch pad was a disaster, and one scientist ended up doing some research comparing it to a volcanic eruption. So the question is, with this second integrated flight test, is it successful? We're going to break it down in this week's episode. We'll talk about both of these test flights, what Test Flight 2 means, and what this means for the future of space and humanity. Welcome to Today in Space. Let's get started. All right, folks, welcome to Today in Space. I am your space science podcast host from the East Coast, Alex Giarfanos, and today we're here talking about Starship. So just in case you're new to Starship or you're just trying to wonder what is this thing that we're talking about here, Starship is the world's most powerful rocket. Now, before that, it was the Saturn V. And the Saturn V was a hugely influential rocket. We have our commemorative edition Apollo 11 Saturn V from Estes Rockets. Good friends over at Estes Rockets. Look out for a giveaway from us, thanks to them, this holiday. But regardless, the Saturn V allowed us to do so many things, and it got us off Earth, right? It got us it was the first time we got human beings on to step foot on another world, thanks to the Saturn V. And those times where this was created were tumultuous and chaotic, but it brought a whole new era of spaceflight and humanity, and for a little while there, some peace. But today, the Starship is the next big thing. And with double the thrust of the Saturn V, the Starship is a beast. One of the things that's really interesting about Starship is that it's made completely with stainless steel, which is not typically what, if you ask like a classic aerospace engineer, they would want to use some crazy alloys like titanium and aluminum, but SpaceX has decided to go with stainless steel. And there's a lot of reasons, but it's going to make it a heavier rocket for, every bit of stainless steel that's put in there. It's just heavier than any of those other metals. So it's a massive rocket which needs a lot of thrust, and there are 33 Raptor engines on board that provide that thrust from the booster, and then there are engines on board the Starship that will help bring it from orbit. And the thing that they tried this time for Starship was the hot separation test, and we'll go into that in just a second here. But Starship has the ability to send human beings across our solar system, right? Not only to the moon, where it's going to help NASA astronauts with Artemis 1 land, it's also going to be possible to bring people to Mars, which is one of the things that SpaceX was designed around. The whole reason SpaceX exists is to make life interplanetary, and the Starship is the big ticket for that. And one of the major advantages of this technology with a ship attached to a booster, similar to the Apollo era with the command module, in here the command and landing module are together. And there's enough room on here for tons of cargo and people, which means it's not only your spaceship, it's also your home while you're there. So this can just be a colony that goes around and flies and lands and makes fuel and makes repairs and goes to the next place. It can do all of that. The booster just helps us get off of Earth. And once we get off of Earth, pretty much anywhere else we would send humans, we've got a pretty good scenario with less gravity, which means less problems dealing with landing and getting off that planet. So we just got to get to that point, and the Integrated Flight 2 was a huge step towards that reality. So let's break down what happened in the first flight test so that we can compare success with the second. All right, so Integrated Flight Test 1 was the first fully integrated liftoff from the pad that Starship ever had. So the booster and the Starship stacked together, working together to get off the launch pad. Now, again, like we said, it's a massive rocket. It's the tallest rocket that exists right now, and it's the most massive. So it's going to take a while for it to get off the pad. So when you see that first flight test, it seems like it takes forever, and that's normal. They don't want to put full thrust at the beginning because you could just destroy everything, and you can always throttle back up once you get off the pad. The other thing that happened with the integrated flight test, it made a huge mess of the launch pad. And we talked about in the intro that a scientist did research on the volcanic eruption, and that was Dr. Phil Metzger. And he was on X, Twitter, and was asking after this for people in the area to take debris samples. And he put together some research that essentially shows that the thrust uncontrolled into the launch pad that launched boulders and debris was equivalent to a volcanic eruption, which is really wild. And while obviously there's an environmental impact, it literally impacted the progress that SpaceX could make. They destroyed the pad. And part of the reason why some of the engines may have not worked as Starship lifted on the first flight test could be directly related to these boulders being uncontrollably jettisoned from underneath Starship. And so there was a lot of work that needed to get done. But in 6 months' time, they had a new booster, a new Starship, and they had iterated on the pad, a water-cooled steeled plate that we'll talk about in a second here. But the pad was destroyed. The ship and booster didn't separate, so they had to be triggered by the auto abort to blow it up, and they didn't have all of the engines fire. So for a first test, it's amazing, but it also opened up a lot of questions and obviously a lot of work for the SpaceX teams to fix things. So obviously they had to work on the pad, but they had to take whatever data they got from this test flight and readjust thrusts, which also would affect all of the propellant loading and procedure. Everything around getting Starship there had to be looked at and revised so that things could be done better next time. And they took 6 months and came back with an amazing test. And there were a lot of things that they fixed. But let's talk about some of that here in our IFT2 breakdown. So for the second test, this was a Saturday morning after it had been delayed throughout that week. As they were getting things together, they actually had to decouple Booster 10 and Starship 25 after they had already static fired and assembled them. They were getting ready for test flight, and one of the actuators on the grid fins of the booster, which would have helped it with orienting and keeping stability of the rocket, never mind on its return home. So they swapped it out, put it back together, and they've taken Starship and stacked the booster so many times since the last time that they've really started to figure things out here. And, within the same day, they found the problem and fixed it and stacked the whole Starship system so that they could get ready for Saturday. And so Saturday morning, they did have a hold at T-minus 40 seconds, and the IFT1 test also had a hold at T-minus 40 right before they launched. So if the next time that you do see a test flight from Starship and SpaceX, if there is a hold, do not leave the stream. There is probably something right around the corner. One of the things that they decided to change, as we saw from IFT1, stage separation from Starship and the booster did not work, and they stayed tangled together until they spun out of control, and eventually the termination system blew them up. And for this one, they decided to go with a hot stage separation. And basically what that means is lighting the Starship engines prior to separation to get things going so that when they do separate, the Starship has a bit of a boost and they get to separate from each other. So it's a technique that was used in the past. It's not like SpaceX and Starship created it, but it is the first time this was done successfully with a rocket this size. So huge kudos to them for getting that right. The boost back burn, however, is not what was expected, and something seemed to go wrong there. Now, it's still early, I'm recording this here on Sunday. the week of Thanksgiving. So this is November 19th. It's just a day after. SpaceX hasn't said anything. Elon hasn't commented yet. But there have been things that he's retweeted, and other people have given their opinions. For us, we saw Scott Manley, and he was saying that it's possible that something with the valves or just the sloshing of all that fuel going as that skyscraper is turning in the sky after being under immense pressure, right? They got through max Q, which is the maximum aerodynamic pressure that a rocket experiences as it's going through the atmosphere and throttling up. And the idea there is that something about the valves that move the fuel turning on and off so that the engines could relight so that it can make the boost back burn, something didn't go right, and it just succumbed to all the forces that were there. Perhaps an engine ended up getting damaged, fuel leaked, something caught fire, and then that's what exploded it. But again, we don't really know what happened other than the hot state separation worked and the boost back burn didn't seem to work. SpaceX wasn't able to land the Falcon 9 for a while, and it was rough getting there. We saw a lot of them explode, but now it's routine. Now dare I say it, almost becoming common, which is crazy considering that not even 10 years ago, people would be laughed out of the room for thinking that's even possible. And another big thing that isn't being talked about a lot, especially if you're just reading some kind of article from folks that aren't talking about space very often, is that the pad survived, right? Twice the thrust of the Saturn V, and the last time the ejecta from going full thrust from Starship was equivalent to a volcano. They introduced this water-cooled plate, steel plate, that basically saved the pad. And so they had millions of gallons of water at high pressure to help prevent those 33 Raptor engines from destroying the pad, and the flame diverter worked well. Everything for the pad seems to have gone by perfectly. So that means that flights can continue. So that means instead of having to spend, like they did in the last 6 months, rebuilding the pad and getting a Starship and a booster prepped for launch, they now only have to focus mostly on figuring out what worked and what they can change, and then assembling a booster and Starship combo that's going to be ready for launch. And so I wouldn't expect anything this year in 2023, but early 2024, I would expect the rumblings of a Starship Test Flight 3, and it's going to be crazy. And if you don't know, there's a thing called Starbase in Boca Chica, Texas, which is where this happened, where this test flight happened. This is where all the Starships and all the boosters are being manufactured and assembled, and the Mechazilla, which is the tower that helps stack and prepare everything and will eventually catch the booster on the return so that it can be reused and turned around. All of that is happening at Starbase. So the question is, was IFT2 a success? Well, let's break it down. We have 4 reasons why we think it's a success here. So, and these are all based on IFT1. So from test 1 to test 2, was it successful? And then what does that mean for the future? So, number 1, pad iteration. Perfect execution by the Starship team. They showed us images a little while ago of a single steel plate, water-cooled, with one of their test stand Starship engines. So one engine, they were able to show that the steel plate was fine, and then they were able to apply that to the 33 engines and create a system and a flame diverter under the pad, which worked flawlessly. So that is just a beautiful piece of iteration and engineering solution and just fixing the problem from last time, which from an environmental perspective, a safety perspective, and even from a, rocket efficiency, every bit of mass that you're blowing out of that hole from firing those engines is less thrust that you're going to get out of an efficiency. You're burning fuel, you only have so much of it, and you've got to get off the ground and accelerate. So knocking these rocks off and not having a surface for that thrust to be fully used, like they did with this metal cool steel plate, is not good. So they fixed the pad, which means now starships can launch more regularly, and it means that the pad won't need work, which means they can just focus on developing Starship, which is what we need them to do. Compared to the first test, all 33 engines fired this time, so that means that they've figured out the dynamics of these wild engines, these Raptor engines, and the whole integration of fueling, methane and oxygen, and getting ready for launch. They had a minor hiccup, a minor pause, and they went back to T-minus 40 twice. But before 9 a.m. Eastern time, we had a launch, and it went great, especially compared to the last one. So huge success there. The hot separation technique can work. That's what this showed. Starship separated and glided on its way further into orbit, was able to light its engines, and looked great. That worked. They did a great job with that. Now, the boost back burn, obviously we know that's got to be fixed, and they've got to figure out how to orient this skyscraper in the sky with these engines and making sure all the fuel that the engine needs to execute that maneuver is given. Those folks have a lot of work to do, but they know so much about this rocket now, and every time they get further and further into flight, they're going to learn more, which means they're going to understand the system more, they're going to be able to get more out of it, and this will eventually become safer and safer with all of this iteration. And the final thing is that routine test flights begin now. The pad is fine, they have starships that are being built and boosters. They're going to start selecting them, putting them together, see how they mate, make any kind of changes that they need to the Starship system from the last test flight from IFT2. This is the beginning of a new era with Starship testing, and we're so excited for it and pumped for it, and what that means for the future. You know, right now, the development of this is going to help these missions that are already planned happen, like Dear Moon, where all of those artists with Yusaku Maezawa, Tim Dodd, the everyday astronaut, is going to be on there, and along with a whole bunch of other people. They're going to be launching. The Artemis mission is going to eventually use the Starship as the way that they're going to land on the moon and then return back to Earth. It is the human landing system that's first going to be used for Artemis, and that's going to be huge. And then there's also the Polaris missions, where eventually a Starship mission will be used for them, and they'll continue to keep testing, and that's only just the start, you know? Routine missions to the moon could be possible, and then eventually a mission to Mars. So there's a huge, huge future potential for what humanity can do in space, and it is very different than NASA, right? And I think that's good. That's what I'm thankful for on this episode, is that, you know, this is nothing against NASA. NASA is a government agency. It cannot fail. The last time it failed, it almost killed the space industry with the space shuttle, right? When those two disasters, Columbia and Challenger, happened, they set back the space industry. Understandably, humans died when it was routine. So NASA is under such extreme pressure that something like what SpaceX does, which is fail fast and learn faster, the iterative process, visibly failing with everybody to then get to the next step, that is something that NASA is just not built today to do. But NASA can be in balance with a company like SpaceX. Look, the last space race, and the reason we had to shift to the space shuttle was because the space race was originally a military budget, right? The Saturn V brought us to the moon. It also helped us start relations with the USSR and Russia in a whole new way at the time, the Apollo-Soyuz mission. And it also allowed us to build Skylab and the beginnings of the space station. So the reason that it died was because public interest died, and there were other things that were going on that money could be spent on. And NASA didn't have that military defense budget anymore to put into developing the program. So what is going to help maintain when public interest goes away, when things out of NASA's control happen and the winds of progress change, what is going to keep space progress going? And for me and this podcast and many other people who've been following along, SpaceX is one of those answers. While it's crazy, right? We get to see them blow up rockets, and there's certainly a different energy with that. It's good because there's a balance between NASA and SpaceX. SpaceX is working with NASA and for NASA and providing technology for NASA. So it's a win-win in so many different ways, and there are so many other companies who are now doing the same thing. It's reinvigorated the space program here in America. We now have the ability to send our own American astronauts into space on American technology, on American soil. That was not the case 10 years ago. And it could have been the end of the space program in this era if it hadn't boomed at the right time. And a major part of that is the innovation and the iteration and the guts of the SpaceX teams. And we're super thankful that those folks exist, that a company like SpaceX exists, and that NASA and them are working together so that we can make progress and not be stuck behind political reasons to go to space and appropriating the right funding. If there's these billionaires that want to put money into going into space and they have good engineering and they have success, I say go for it. And in the meantime, we can start to build a better world if we have something to look forward to. And I think that's what Starship is something to look to the future in this crazy time and dream bigger and think bigger. And, what a perfect example of challenge, right? IFT1 in many ways could be looked at as a failure. They destroyed the pad. They had a whole bunch of what you could consider environmental damage. Their rocket didn't separate. They had to blow up their rocket and then recover all that debris. And they had all of those challenges of the FAA getting all of the things checked off, and the organizations needed to get the license for the next test. It was a crazy 6 months. But they figured it out. And not only that, they fixed so many of the things that were problems that are not a problem anymore, like the launchpad and all 33 engines firing. The hot separation technique unlocks orbit for Starship now. And now we're on our way to routine tests for the first time. So this is a hugely important day in space, and we're super thankful for all the people that are involved in making this happen. From the very, very top at NASA and the folks like Administrator Bill Nelson, who's leading NASA, all the way down to the barista at Starbase, who's making coffee for the employees and the people at Starbase, and all of the brilliant engineers. And of course, thanks goes to Elon for putting all of his money into those first attempts of getting the Falcon 1 off the ground and continuing to pump money into this thing so that things can happen. They're making progress, and we're super thankful for that. So we want to thank you for joining us here on this episode, a Thanksgiving episode, and we're thankful for Starship. We're thankful for the success of IFT2, and we're thankful for you for being a part of this. So thank you for listening and watching this podcast. I am Alex Giorfanos, your space science podcast host from the East Coast. Thanks for joining us, and we'll see you in the next time on Today in Space. See ya.